Okay, so moving into the third subtopic in monitoring the environment, volumetric analysis. Hopefully this will be a lot of revision from last year, but I will try and go through everything just in case you've either forgotten or maybe there's some stuff that you haven't seen from last year. We'll divide this one out probably over about 4 videos, and in the first one we'll focus around concentration units. So, what's our science understanding for this one? Concentrations can be described by using a number of standard conventions. They include we can calculate concentration and interconvert units, and the units we'll be using are moles per litre, grams per litre, percentage weight volume, parts per million and parts per billion, and we can apply the SI prefix conventions to quantities. So we'll just deal quickly with this second one first. This is where you're probably familiar with this. Kilo is times something by 1,000. So a kilogram is 1,000 grams. A kilometre is 1,000 metres. A millimetre is 1/1000th of a metre. So that's 1 over 1,000, which is equal to 10 to the minus 3 in our scientific notation. A milligram is equal to 1,000th of a gram. A microgram is equal to a millionth of a gram. Or a micrometre is equal to a millionth of a metre. So a millionth is 1 divided by a million, which is 1 divided by 10 to the 6, which is equal to 10 to the minus 6. So we use these prefixes when we're describing really small numbers or really large numbers. So going back to the concentration information, we'll start off with talking about what is a mole. And a mole is, 1 mole is equal to 6.023 times 10 to the 23 atoms or molecules or particles, whatever what we want to say. If you're wondering where that number comes from, if you have exactly 12 grams of carbon 12, of the isotope carbon 12, then you would have 6.023 times 10 to the 23 atoms of carbon. It's a lot of atoms of carbon in 12 grams because the atom is very small. We call that number also Avogadro's number. Now, this can cause a little bit of confusion. M is what we use for mass in chemistry. But mass in chemistry is usually measured in grams, whereas in most other subjects we would say that the standard international or the SI unit for mass is kilograms. Chemists are a bit rebellious and they use grams. Capital M stands for the molar mass or the molecular mass or the atomic mass. We tend to use all those terms interchangeably, and it's the mass of 1 mole of an atom or molecule or ion or compound. And those molar masses or the atomic masses are all given on the periodic table in little brackets under the numbers, and we can add them up to get our molar masses for a molecule or a compound or something like that. If we want to convert between the number of moles, N, that's the symbol for number of moles, and mass, we use this formula here. Number of moles equals mass over molar mass. And conversely, later on, if we want to work out mass, we rearrange this formula, times both sides by big M, the molar mass, and we get mass is equal to, let me just change my pen, mass is equal to number of moles times by molar mass. I've talked about already what a milligram is, a microgram. Litre is our standard unit of volume in chemistry, so not cubic metres, which is probably the standard one from physics and SI units. And our standard unit for concentration, C, I probably should have labelled that concentration, but hopefully that's obvious, is moles per litre, mole L to the minus 1. And the formula for working out concentration in moles per litre is N, number of moles, divided by volume. Again, sometimes we want to rearrange that formula and we would want to work out the number of moles, and there, that number of moles equals concentration times volume. So we both times both sides by volume to get that conversion. Other units that we tend to use a little bit are grams per litre. Pretty self-explanatory, I would hope. Percentage weight volume, which is how many grams per 100 millilitres. I think when we give you a percentage in a test, it's like converting your mark to out of 100. So if you get 25 out of 50, that's 50%. It's like saying, well, if you got 25 out of 50, that's like getting 50 out of 100. That's what the percentage is. Grams per 100 mil, percentage weight volume. It's how many grams in 100 mil, so out of 100. Parts per million. Best to think of parts per million as milligrams per litre. If you're wondering where the million comes from, milligrams per litre, well, a milligram is 1,000th of a gram. 1 litre is equal to 1,000 mil. 1,000 mil would equal also 1 kilogram or 1,000 grams. So you've basically got 1,000 here and 1,000 here. 1,000 times 1,000 is a million. That's where the million comes from. Parts per billion is micrograms per litre. 1,000 grams or 1,000 millilitres in a litre, so 1,000 grams in a kilogram, and 1 kilogram of water equals 1 litre. A microgram is a millionth of a gram, so a million times 1,000 is a billion. So that's where the parts per billion comes from. To convert between these units, if we want to go, we'll start with grams per litre. If we want to go from grams per litre to moles per litre, what we really want to do is convert grams into moles. If we want to convert grams into moles, it's like using this formula here, and we just divide by the molar mass. And if we want to go the other way, from moles back to grams, then we times by the molar mass. If we want to go from grams per litre to milligrams per litre, 1 gram is equal to 1,000 milligrams. So what we're really doing here is timesing by 1,000. And if we want to go the opposite way, we divide by 1,000. And there are 1,000 micrograms in a milligram, so 1 milligram equals 1,000 micrograms. So if we want to go this way, we times by 1,000 again. And if we want to come back this way, we divide by 1,000. And finally, we have our percentage weight volume. So 1 litre is equal to 1,000 millilitres. So if you like, this is a tenth. There's a tenth as much in a 100 mil as a litre. So we're basically 1/10. We're dividing by 10 when we go from litres to, from a litre to 100 millilitres. It's a tenth. And if we go the opposite way, we need to times by 10. Now, if we need to go 2 steps, I would just do it 1 step at a time. So if we wanted to go from moles per litre to parts per million, I would times by the molar mass, and then I would times it by 1,000. If we wanted to go from percentage weight volume to moles per litre, I would times it by 10 and then divide it by the molar mass. So just do it step by step. When I do an example calculation in, I think it's it'll be the 3rd video in the volumetric videos, I will actually go through a unit conversion because there's one there in the example calculation that I'll do. But that's all for now. Thank you.